Hello there, and in this video what we're going to be talking about today is the language of science. So what these are some terms that you're going to be hearing throughout the year and should probably be familiar with. So we're going to talk about a few examples, definitions, and by the time this is all said and done, you should have a very good indication of what these terms mean. So let's go ahead and get started, shall we? The first of these words that we're going to discuss today is belief. So simply put, a belief is an opinion that does not require evidence, and it's often based upon societal or religious teachings or even ethics. So for example, for the most part, people are pretty good. People are pretty good. That's an opinion. Other examples of a belief include astrology, or using the stars to go ahead and predict one's future. So think about like reading your horoscope online or even in the newspaper if you still do that. Other examples of this include personal opinions. So for example, this could include your favorite color, your favorite type of food, or in this case, your favorite sports team. For me, my belief is that the Pittsburgh Penguins are one of the greatest hockey franchises of all time. Now, I've included the fact that the Capitals are here, so, I mean, look, it's an opinion, it's a belief. It doesn't really require evidence. You don't have to go ahead and validate to me why you like something. That's what makes it a belief. Up next is a hypothesis. Now in science, I'm sure you've heard hypothesis before this point. But simply put, a hypothesis is a testable statement. So it's a question that we intend to answer, but it has to be testable. It's the effect of the independent variable, what we change, on the dependent variable, which we measure. We'll be talking about this a little bit more in depth later on in the year. And it's often written as an if-then statement or format. So for example, like the picture states, if plants are given Red Bull, then they will grow more quickly. So it's testable, it's an if-then statement, and we're measuring the effect of the IV, or the independent variable, on the DV. And that pretty much sums up a hypothesis. The next one we're going to talk about today is a theory. So a theory is an explanation of how and why something happens. These can be based on observations and even prior experiments if they exist. Now, theories can be tested, but they cannot be proven. However, if there's enough evidence to go ahead and refute it, theories can be disproved over time. Some common examples of theories include the theory of evolution. So if you think back, there's fossil record, there's genetic evidence, there's evidence to back this up. And it could also be tested. However, we can't 100% prove it. And the same deal with the Big Bang Theory. There may be evidence to support it. People have definitely done the research, but at the end of the day, we can't 100% prove that that's what happened. So simply put, a theory, how and why, based on observations, can be tested but cannot be proven. Up next is a fact. So a fact is an observation that can be measured with the same result each time. So for example, the Earth is round. I suppose unless you're one of the flat earthers, but hey, you do you. I'm not here to judge. Also, pi is always going to equal 3.145, etc., etc. This is why I teach bio, not mathematics. But a fact is something that can be measured time and time again with the same result. And our final term that we're going to go ahead and discuss today is a law. Now, a law, unlike a theory, explains what happens, not why and how, but what. And it often involves a mathematical formula. So these are the summary of many experiments and observations accumulated over time. And simply put, these have been tested so many times that we no longer need to be tested. We no longer need to test them to go ahead and accept that it's true. For example, force. Just like Mr. Tyson down here, the force of a fist going ahead and hitting somebody's face, that force equals mass times acceleration. And also in the top picture here, we have gravity. Gravity is always going to be acting upon an object, at least in our atmosphere, at 9.8 meters per second squared. And that right there is going to go ahead and sum up our first video here on the language of science. So like I said, if you go ahead and you ever miss something, feel free to pause, go back, and take a look at it. But now you know. And until next time, you take care.